In this video, I'm going to go through some system information commands for Linux. What I've got here is a basic topology. I've got a host running Debian version 12, and I have a server running Ubuntu version 20, and they're connected with a couple of switches. As a network engineer, it helps to know some of the basic system information commands for Linux. So what I'll do now is select the console, and then terminal. So you notice I'm signed on as root, and that's the top level host administrator. If I do an ls, this will give me a list of the directories. You see there's nothing there. So the default is my home directory. So I need to go up one level to the root. So I'll go cd and then /. If I go ls, and these are the standard directories for Linux: bin, dev, home. So network engineers would often be interested in etc. and var for the directories. So what I want to do is just start with a who am I. And this shows that I'm signed on as root. As mentioned, that's the top level administrator. And the next command is cat etc. os release. So the cat command just lists the contents of a file. So here there's an os release file in the etc. directory. An os release will just give me some information on the current operating system information. So this shows Debian Linux 12. And the code name is bookworm. And some other links there, just to give me information on the current Linux version. Now, if I want some more specific system information, I'm going to use the uname command with an A option. So what this command does is provide some more information. It provides the kernel version, and that's 5.15. It's also got the Ubuntu information, that's version 20. It's also got the hardware information, x86-64. This helps with software bugs, for example, if you want to verify if there's a problem with a specific version of Linux. Now the next command is hostname. And this is just the name of the actual host. That's whether it's a host or server or some network device. And here it's just a host. Then there's also uptime if you want to know how long the device has been up. And this will give you the information here. It's been up 32 minutes. I'm signed on here directly, so there's no other remote users connected. And give you some load information as well. And if you want to know when the last reboot was for the device or the host, then you use the last reboot command. So if you were wondering if there were changes to the device, you could look at the last reboot and find out when that was. And the date command will give you the current date and time. In this case, it's using UTC. Then there's this W command, and this will give you all information on any of the users remotely logged in. Currently, there isn't any as mentioned, but if there were remote users logged in, you'd have them listed under user, and then the TTY terminal number they're using, and some other information. So that's helpful as well. Finally, if you want to look at the amount of memory available, because this always helps know with Linux, just do the free command. And if you use /g, it'll give it to you in gigabytes. So without the G, it'll give you something like that. So in this case, this is megabytes. So half a gig is used, shows you what is free. So that helps to know if you're running out of memory. So that gives you an overview of the system information commands that network engineers can use. And the next lecture is going to be the ls command and security rights. In this video, I'm going to discuss the ls command. That's the list directory command for Linux, and also security rights. So the default is the home directory. That's where I am right now. So if I run the list command or ls command, there's nothing there because I don't have any current files in my home directory. So what I need to do is go up one level to the root directory and get a root listing. That's the cd// command. Now I can run ls. So what I've got here is a nice listing here. Of interest is the etc directory and the var directory. And that's where a lot of the networking files are. So if I use the ls/l, this is often a little friendlier as well. And what I'll get also is the security rights. So that's important. So the listing is much better. I'll get on the left here the security rights. I'll get the owner, and I'll get some data information, as well as the size of the file or directory. So notice with the security rights, there's actually 10 characters. Their security is pretty straightforward. So on that first character on to the left, if it's a D, it's a directory. If it's L, it means a symbolic link. And that's similar to a shortcut. So it's really a shortcut linked to another file or pointing to another file or a directory. And if that's a dash there on that first character, that refers to file. So what I'll do is I'll select the etc directory here. This is the fourth line. So I'll go over here, and what I've got is this is a directory because it's a D. What I've got is 9 characters after this. And the first 3 characters represent the security rights of the owner. So here the owner has R, W, and X. That means read, write, and execute for that directory. Or if it were a file, it would have a dash, and it would have the same rights to the file. The second group of 3 characters represents a group. So a particular group would be assigned to this directory and have rights. And currently with etc, they're only permitted read and execute. The write is not available. So that dash there would mean they don't have that write security permission. Then the third group, that's the 3 characters. This is R, dash, and X as well. This belongs to others. This just means everybody else. They have read and execute and do not have write privilege. The read command permits you to list the contents of a directory and also subdirectories. And as well, if it were a file, then you could read the contents of the file with a cat command. And the W command is write privilege. And that permits you to create, rename, or delete a directory. And if it's a file, you could create, edit, delete, or save the file. And finally, there's the execute command. And with that, you can actually CD between directories if you have that right for that directory. And if it's a file, that means you can run a script or an application. So that gives you an overview of the security rights for Linux and what that means. And you've got 3 sets of 3 characters for each, and they represent owner, group, and others. What I can do is change directory with CD. I'll just go to etc. That'll give me a listing of the etc directory. And if I want to make a directory, a new directory, that's just mkdir, make directory. There it is there. Then I'll just do an ls again. Notice it's right there. There's the directory I just created, CiscoNet. The other thing to note with Linux security rights is sometimes the security rights are assigned as numbers. So for example, I've got this CiscoNet directory here, and as an owner I have RWX, that's all rights. Read is assigned 4, W is assigned 2, and X is assigned 1. So that would add up to 7. So with 7 I have all access. Then the next 3 letters refer to the group, and that's R-X. So they would get a 5 since read is assigned 4 and X is assigned 1, and that adds up to a 5. The same with the other. That's R and X. That's a 5 as well. So this will be shown as 755. And you'll see that listed sometimes instead of using the letters. To remove directory, it's RMDIR. That's remove directory. I would just type the name of the directory. That's all there is to it. Then I'll just verify it's been deleted. This is all in alphabetical order. You notice CiscoNet's deleted. So that gives you an introduction to the ls command and security rights for Linux. And that concludes the video. In this video, I'm going to show you how to use the CD command. That's the change directory command for Linux. So just select host here, console. I'll start a terminal. The first thing is mentioned, this is my home directory. I'll just do ls. I have no files in there at the moment, so I need to go back up to the root level, cd/. I'll do an ls/l. So what I want to do now is go to the etc. directory. So to do that, it's just cd etc. And within etc. there's a network directory. That's important for network engineers. Just go cd network. There it is. You can do an ls/l. And you can see based on the listing, there's 5 directories and 1 file. The file is this interfaces here. And this is quite important for network engineers, since it's got all the information on the IP addressing. Now what I want to do is go back up to the root level. So I'll just go cd/. And now the other thing to do is I can also do it as a path. So to do that, I would do cd and / etc. and then / network. And that does the same thing. So you can do it, either method works. Now say I want to go back up to the etc. directory. So that's up 1 level. So I would go cd space and then 2 dots. And that takes me to etc. Now if I do an ls/l, notice this has a lot of files and a lot of directories. This etc. directory. I'm just going to up arrow for the last command, and I'm going to use more. What that'll do is give me one screen at a time. Starts at the top here, goes right to here. Then I'll use a space bar again. That'll bring in the next screen. So it just, instead of giving me a full listing, it'll give me one screen at a time. This often helps if you're going to do a search on a file or directory. And there it is there. So that's a good command to know as well. And that concludes the video on change directory. In this video, I'm going to show you how to use the Linux cat command. And the purpose of the cat command is to list the contents of a file. We'll start a console again. So for network engineers, 2 of the most important files are the host file and the interfaces file. The host file is the DNS file. That's where you have a mapping between IP address and host name. The other one is the interfaces file. We've got the IP configuration for the network interfaces. So before that, I'll start with the hostname file. So I'll do cat, then I'll path to the etc. hostname file. There it is there. If it was a firewall, for example, it would be something like maybe FW1 or something, or a server or something else. That's the current configuration of the actual host name. Next thing I'll do is look at the host file, and that's the DNS file. So I'm just going to up arrow, and that'll just repeat the command I previously did. I'll just edit this for hosts. This is an important file. So what I've got is the loopback, that's 127.0.0.1. That's called the local host. And I've also got the IPv6 loopback interface. That's that 2 colons and a 1. And some other IP6 addresses. And that's basically it. There's no other current mappings. Now I'll just up arrow again. This time I'm going to go to the network directory. And the interfaces file. So if you configure the interfaces from the GUI, you would just uncomment these first 2, auto Ethernet 0, and also this second line that's got this static address. Then there's the standard IP address, network mask or subnet mask, and also the gateway address. In this line with the name server, this points to this file resolve, and this lists the name server or DNS server that the host is using. There's also the DHCP configuration, and also add static IP routes here. Now I'm just going to go up and do one more. This is to the time zone. And that'll just show configured time zone. For here, it's Eastern Standard Time. can also use the cat command to create a file. So for example, if I use cat and then greater than symbol, and then give a name of a file, say commands.txt. I can start typing since it's an empty file. So I could type something like that. Then I could hit enter, and then just Control D. Then I could do an ls/l. There it is there. I'm currently in my home directory. So that's created that file, and I do cat. It'll just list the contents of that file. Finally, if I want to remove the file, it's just rm and the name of the file. And see the file's been deleted. That concludes the video on the cat command. In this video, I'm going to show you how to use Nano Editor to edit configuration files. So the Linux configuration model is somewhat different. For example, you can change configuration of the interfaces or host file, or really anything else at the command line. The problem is that it's not a permanent change unless you go in and edit the files specifically. So if you want the changes to be permanent for anything with Linux, you have to go in and actually edit the files. So what I'm going to do is start a console. And then start a terminal. What I'm going to do in this example is show you how to edit the interfaces file. And that's where you've got the IP addressing and some other settings. So the command is nano. The interfaces file is in the network directory under etc. So this starts the Nano Editor, and it really is a lot easier than using ViEditor. It's basically similar to using Notepad. So what I'll do is I'll go over to this IP address here, and I'll change this 1 to a 3. So that'll change the address to 192.168.1.3. And I'll leave the subnet mask as a /24, and also the gateway address is the same as well. And to change the name server, I'd have to update the resolve.conf file. But I'm not going to do that here. Hostname I'll change to CiscoNet. This is where you'd also add static routes if you wanted to. So what I've done now, I've added this interfaces file. This is going to make it permanent. If I would have used a command like IP address command, for example, just to change the IP address, it will work, but it doesn't change the actual interfaces file. And that's why it wouldn't be permanent. So he's mentioned I have to go in and actually edit this interfaces file to make it a permanent change. So then it's Control O. This is going to write the changes. Hit enter. That's all there is to it. And then Control X. So what I'll do is up arrow. And I'll choose the cat command to display the interfaces file. You can see the changes made there. It's 1.3 there for the IP address. And the host name is CiscoNet. The other thing to mention with the host name is if you change that, you also have to update the host file and the hostname file, since it's not done automatically. So what I'll do is I'll edit the host file. And this is the DNS file, of course. And at the top there, I'll just change that host to CiscoNet. And so that just changes it. That's just the local host name or the loopback. I can also go here, I hit enter. I could do something else like maybe another mapping for a server, maybe 3.1, and I'll call that web server, for example. So I can edit this host file as well. This is a DNS mapping. These are A records. And so that's easy enough to do. And then just Control O, hit enter, and Control X. And the other thing is just the hostname file. So I just up arrow here. There's the hostname file. That's in etc. directory. And it's just a question of putting in the new hostname, CiscoNet. So that'll be Control O, hit Enter to write it, and Control X. And while I'm doing this, I'll just show you the resolve file. This lists the name server. And there's the name server. That's the DNS server, and that's the address. So I don't really have any DNS set up here. It's the same as a Cisco name server iOS command. Now what I'm going to do is restart this to make sure the changes are permanent. So I'll just do a stop and start. And I'll select terminal. You notice there CiscoNet now is the new host name. I also want to verify the interfaces file has been updated as well with the correct IP addressing and host name. That's the cat command. Notice there the IP address is 1.3, so that's correct. And the host name is CiscoNet. And that concludes the video. In this video, I'm going to show you how to use the grep command. This command is used to do searches through a text file. It's to do a search for a pattern string. So I'm going to go to this server here. So what I'm going to do is start a terminal session here. I'm just going to expand this window. What I want to do is a search through the syslog file. So I'll go up to the root directory. And I'm in the log directory, and I'll just do ls. There's syslog there. So I'll just do cat syslog. And there's a bunch of stuff there. I'll just do a clear. I'll do a cat syslog. Then this is this pipe command. Then I'll just use grep. I'll search for duplex. You notice when I do that, it'll search that syslog file, and it'll just highlight all the lines that have duplex. Say I've got a problem with an interface, and I'm wondering if it has to do with duplex. So I'll just use something like that. It'll search through and highlight in red all the occurrences where there's duplex. Just do a clear. There's also this other command called tail command. And what that does is that will list the last entries in the syslog file. Say I want the last 10 entries. Those are the last 10 in the syslog. So that's basically all there is to that grep file. Like I said, it just searches through for specific strings of words and makes it easier to do troubleshooting. And that concludes the video. So to start with, the TCP/IP architecture model is really the de facto architecture standard for network communications. It supersedes the OSI model that was used previously, but with the move to internet applications, the TCP/IP model is better fit for the applications being developed today. So it is the standard for network communications. It's got 5 layers. Primarily what it does is it supports network communication. It really supports it based on interoperability among really any application you want. It makes no difference whether it's in the cloud or on-premise. The applications themselves, whether it's Linux-based, Windows-based, or really any other platform, you can communicate via this model. So it's just designed for each operating system. The network communications layers of the model, being the transport and anything below that, will communicate across the network by establishing this network connection. Software is embedded with each operating system. Like I said, you can plug in your web applications into this easily. You've got the code layer that developers work at, and you can plug into the application layer via APIs and, of course, with the operating system calls. It's a popular framework to understand networking concepts, so you can really understand networking by starting with this model. It really is the way to learn networking, how HTTP fits into this model and allows you to communicate across the network. whether it's internet or private applications. And it's good for network troubleshooting as well. You'll learn how to do a lot of network troubleshooting in this course, and really application troubleshooting as well. And it'll all be based on these 5 layers, starting from bottom right to top. So like I said, it really does supersede the OSI model. The OSI model is an older model that was developed a long time ago, and it really was pre-internet. And the only difference between the two is you've got an application layer here. Like I said, you've got 5 layers to the TCP model. The OSI model has 7 layers. But what's happened is the 3 top layers, the session layer, presentation layer, and application, is really collapsed into a single application layer. It's quite substantial as far as the architecture goes, because now you define all your services with one layer, and that's how it should be. And so you can connect your applications by just one layer. That's all you have to concern yourself with, is any calls or anything goes right to the application layer, whether it's an API or some application layer protocol. So it makes it a lot easier, and the TCP/IP is more IP oriented as well. So we've got really 2 groups of services here with the layers. The bottom layers are really hardware oriented. It provides the network access to the network. So you've got a physical layer, and then you've got the network access for these 3 upper layers that are really software oriented. So the bottom level is bottom 2 layers are hardware. The top 3 layers are software. And it's a layered services architecture. So each layer requires that the layer below it is working. So each lower layer provides services to the next upper layer. So you have to have the hardware connectivity before you're going to have any packets sent across the network, any application connectivity. The software layer is routing, host-to-host connectivity, and process-to-process, meaning inter-process communications with the applications. And here I've got some network protocols and associated layers, just to give you an orientation of the protocols themselves and really where they're fit. I'll go into a little more detail, but it's nice to know to get that sort of orientation. At the bottom, there's some really physical layer protocols, and these are associated with cabling and wireless and part of the specification that's at that layer 2. So you've got 1000 base T, that's Ethernet cabling. MIMO is wireless connectivity, and DSL, that's a WAN communications protocol. On layer 2, there's things like Ethernet. And Ethernet is the protocol you're most concerned with as a web developer. It really provides a connectivity from the servers and applications to the switches. ARP is another protocol that's good to know because that sets up the network communications. So it's a mandatory protocol. Audio 2.11 is the wireless, and that's really part of the wireless standards. And there's several wireless standards, and they really are concerned with protocols at layer 2 as well as the specifications at layer 1. And then point-to-point protocol, that's something DSL would use. That's for WAN connectivity. Like I said, as a web developer, you're really more concerned with the LAN side of things. Then on layer 3, that's the network layer. You've got IP, of course. You've got other protocols like ICMP for messaging, and OSPF, EIGRP, and BGP. And they're routing protocols for getting the packets across the network. And then TCP and UDP, they're the host-to-host connectivity protocols for maintaining that host-to-host connection from client to server. So it's more of a virtual connection. And right at the top, you've got HTTP, and of course HTTPS as well. And then DNS, TLS, SSH, SMTP, and FTP. These are some of the most important protocols as a web developer. It's something that I'll go into more detail in the network services section. And then finally, there's these TCP/IP architecture components. And the purpose here is just to show you that there's 5 different components at each layer. You can really specify something at each layer that defines the layer itself, and they're all described here. A connection, for example, you've got a physical connection at layer 1. Then at layer 2, it's an interface connection. That's Ethernet, of course, and some of the other protocols mentioned at that layer. Then there's routing. That's a logical connection between routers, for example. Then you've got a host connection. That's really more of a virtual connection. between client and server. And then interprocess really defines the connection between browser and web server software. Then the services are defined at each layer. Each layer provides services to the next layer. So the cabling and wireless at layer 1 is providing services to Ethernet that needs a cable to, of course, send data across between devices. Then you've got routing services on routers. You've got addressing at every layer except for the physical layer. You've got flow control, and that applies really at the transport layers. That beats something like TCP, and loss recovery is part of TCP. So these services are all defined at each layer. And you've got the protocols. A lot of those have already been mentioned, and they're really assigned to each layer. And addressing, of course, is really key to network communications. And every layer has its own type of format. For Ethernet, it would be a MAC address, and that's a physical address that's burned into the network adapters. You've got an IP address, and that's everything. Every network node needs an IP address for communications and for routing purposes. Then you've got a transport socket, and you've got lots of those. They run on the client and the server for that host-to-host connection. And then you've got a session ID. That's just another example. And that would be application layer. And the protocol data units, these are, you might be familiar with some of these. The bits of just serial bits are physical layer, what's called a PDU. It's just defined at the physical layer. Then you've got frames, and that's really at layer 2. That's Ethernet. Ethernet builds frames. And layer 3, you've got packets, and they're actually part of what IP carries, the IP addressing in packets. And segments is associated with actually TCP. And then data is, of course, the HTTP application layer. In this section, I'm going to be discussing networking commands. And this is important for network engineers since I'm going to go through show commands for troubleshooting purposes. In this video, I'm going to discuss the IP link command. And the IP link command covers layer 1 and layer 2 of a network interface. So that includes the physical connectivity as well as the data link connection to the switch. We'll start a terminal session here. So the command itself is IP link. There's also a show that's added automatically to this command, so you don't need to add it. So I'll expand the window a little more here. The command's a little cluttered. There's a lot of information there. It shows both interfaces are currently active, and that's Ethernet 0. The top one is the loopback, and that's automatic. So Ethernet 0, that would be the network interface on the host. So the Ethernet 0 could be a host interface, it could be an interface on a server, or it could be an interface on a network device. What I'm going to do is go to the Ethernet 0 interface. Notice there's two upwards here. There's the first one, and then there's lower up. The lower up, that's layer 1, and the other one is layer 2. So you're getting something similar to a show interface command from Cisco. And there's also the MTU value of 1500. That's a default for Ethernet. And in addition, you've got the MAC address there, as well as the broadcast address. And that's all Fs. There's another command that cleans this up a little. So I add a BR, and then link. It'll give me something just a little cleaner, just by adding this BR. So there's the loopback and the Ethernet. And they're both showing as up. They got layer 1 up and layer 2 up on both. So that's fine. There's no problem there. The loopback's actually a logical interface. So all I'm looking for is an up on that. But the Ethernet definitely refers to layer 1 and layer 2. I can also just look at a single interface as well. And I'll just do IP link show ETH0. And that'll just show me the Ethernet 0 interface. Now, if I want to shut down this interface for some reason, I would use the IP link set command. So that's IP link set ETH0 down. And that's all there is to it. So that's administratively down now. So I'm just going to up arrow and find that IP link show again. there's no 2 up values there. There's nothing at all. So this is actually state down. You see it right there. So that's what it'll show you there. And if I want to bring the interface back up again, I would just go to use the up value. So this is IP link set 0 up. And that'll enable the interface. I'll do the same command. I want to take a look at it. You see it there. So I've got up and lower up. And that's a working interface. I'm just going to clear this. Now there's also a command to look at statistics of an interface. And that's IPS link show. And S is for statistics. And I'll use Ethernet 0 again. This will give you some information on the interface itself. Similar to show interfaces for Cisco. So there's the MAC address. And there's the receive and transmit direction. So for receive, there's number of bytes received, number of packets, number of errors, packets that are dropped, and missed and multicast. And same for transmit. So at this point, I could do a ping to the server. Now we'll look at the stats again. Notice there's more bytes sent, packets sent, no errors of any kind. So that'll tell you if there's errors on the line and how many bytes are sent, also packets. And there's also a command to configure the MTU. You'll do that sometimes if there's a tunnel between source and destination. So that's IP link set. So I could set it for 1400. If I do a show command, notice MTU is now 1400. So that's another command that's helpful for network engineers. And that concludes the video on IP link command. In this video, I'm going to discuss the IP neighbor command. This command is more specifically layer 2 only. It really tests the link between host and switch. And this is the data link connection. So it'll tell you if you've got a neighbor connection based on ARP and verify that ARP is working correctly. So we'll start a terminal session. And is IP neighbor. And you'll notice there's nothing there. So the problem is I haven't initiated a connection to the server, so ARP hasn't had the opportunity to make that connection. So what I'll do is I'll ping the server. I'll just send some pings to the server, and this will initiate ARP. So Control C. Now we'll go IP neighbor again. Now I've got this reachable message. So this is really the ARP table you're looking at. It's got the IP address of the server, 192.168.1.2. Ethernet 0 is the interface. There's the MAC address. It's mapped to the IP address and showing as reachable. So that neighbor connection is working and the ping's working. So what I'll do is I'll stop the server now. I'll go back and do this IP neighbor command. So I just up arrowed there. It shows as stale, meaning that there's no ARP connection there. So in Linux terms, that tells you the layer 2 connection isn't working. So I'm going to do a clear here. Now we'll do an ARP/A. This is showing the actual ARP table. The other command, IP neighbor, really tells me the connection status or the operational status. And there's a question mark. So this shows me that ARP isn't working. There's a problem with the layer 2 connection. And if I do ARP/V, this will give me more detailed information. So with the hardware type, the address, and the hardware address, and any flags and the Ethernet interface. What I'll do is start the server again. Just do an IP neighbor. And it's stale, so I have to send a ping again. And there it is there, it's reachable. So that's layer 2. And that concludes the video. In this video, I'm going to move up to layer 3 now and show you the IP address command. As mentioned, this IP address command is similar to something like ipconfig. It also replaces the deprecated Linux command ifconfig. So it's just IP address. That'll give me this listing here of both active interfaces. Top one's the loopback, and the second one's Ethernet 0. You can see I get the layer 1 and layer 2 here. It's up and lower up. The first up is layer 2. The second up is layer 1. That's the cabling or wireless connection. And you'll notice the loopback is this 127.0.0.1, and that's sometimes called the local host. So it's just a loopback interface. There's also an IP6 loopback as well, this 1.128. Looking at Ethernet 0, there's the MAC address there. There's the Ether. And that's the MAC address right there in the broadcast. And then the iNet, that's 192.168.1.1/24. So there's the IP address. And that's basically all there is there. And that tells you the interface is up, layer 1, layer 2, and layer 3. You can also do the IPDR as well. That'll just give you something a little cleaner. So this is just quickly if you want the IP address. It'll show you the loopback and also Ethernet 0. That just gives you a little cleaner display. And if I want to look at the individual interface, this would be IP address show device Ethernet 0. That'll just show me a single interface instead of listing all of them. Some devices you might have maybe 10 interfaces. So you just want to look at one interface and just use that command. And you'll notice as well, this is reading it right from the interface's file. If I go to that file, that's in the network directory. That's called interfaces. And it's just reading this same file here. So it's all right there, including the host name. Though that's not included with the IP command. So if you wanted to change the IP addressing permanently, you just start a nano editor and edit that interface's file and just do the changes there and then do a save. And that concludes the video. In this video, I'm going to show you how to do open port testing with Telnet. So at this point, it's going to be layer 4, a transport layer. And Telnet's a nice application that allows you to test what open ports are available on a server. And this is nice for troubleshooting. The command is telnet, then open, and then the IP address of the destination. And this is the server 192.168.1.2, and the port is HTTP. That's TCP port 80. And you'll notice there that does connect. If there was a problem where the server wasn't listening on port 80, I would get a connection refused. So that's actually working okay. So it is connected to 192.168.1.2. So that's working fine. So Control-C to go back. Now with GNS3 and the server, there's no certificate, so it only does HTTP. So if I try port 443, that's HTTPS, it won't work. So I'll just try this, make sure. Open 192.168.1.2. And TCP port 443 is HTTPS. There's connection refused. So the server's not listening on that port, and that is not currently supported. You can also try FTP. There is an FTP server on that server. That's 21. And that's working okay. There it is there, FTPD. That's the service on the server. The FTP server is working okay. Now the other Linux command for transport layer, or layer 4, is SS command, and that stands for socket statistics. And this is the replacement for netstat. Netstat is pretty much deprecated with Linux. So now the new distro has SS. What I'm going to do is I'm going to start an HTTP session and also an FTP session. Then I'm going to show you the results of SS. So we'll go to Applications, Mozilla. So that's the HTTP session active. I'm going to start another session. This will be FTP. I'm just going to telnet there. And that's TCP port 21. So that's active. Now what I'll do is SS. And basically at the top here, there's not too much. Some of these are just default ports. Turning at the top here, there's nothing of interest there. But at the bottom here is where you'll have the current listings. And they're both TCP, since HTTP and FTP are TCP applications. And then there's the source, 192.168.1.1, that's the host. And there's the ephemeral port, that's the temporary port. That's the source port. And the destination port is HTTP and FTP. So it's not showing the number, it's just showing the keyword there. And the destination 192.168.1.2. Go to the top here, shows you the local address and port and the peer address or the destination address and port. So there's HTTP and FTP at the bottom. I've actually got two FTP sessions running. If I do SS/P, that'll give me the process ID. You see right at the bottom there. So from the left, there's the TCP protocol. It's established, so that's a TCP established session. There's the source socket, 192.168.1.1 in the TCP port, that's ephemeral. Then the destination, 192.168.1.2. Got FTP on the one session and HTTP on the other. And the one's using Firefox, that's the web browser. The other one's using Telnet to access FTP. So the /P will give you the process ID as well. And that concludes the video. In this video, I'm going to show you how to use NSLookup. NSLookup is a popular tool for getting information on a DNS server, as well as verifying that the DNS server is operational and working correctly. So this is a Windows command line. So if I do NSLookup and do something like, say, teachable.com, what it does is, the first thing it does is it's going to show me what my ISP DNS resolver is. And we've discussed this in the video of what that is. It's the connection, it's the ISP service that has DNS servers. So this is the actual host name of the DNS server, the ISP DNS resolver, and there's the address. It's showing IP6 address. So that's the first thing. So that's good. The DNS resolver is responding. Then it gives me a non-authoritative answer. So that means that it got it from its cache. It didn't get it. It got it from an authoritative server at some point, but it's actually saying this is coming right from my cache. So I didn't have to go out to the authoritative server. I did at one point, but I've got it cached locally. And there's the name, teachable.com, and there's the address. It's giving me actually two different addresses here, both for, actually it's giving me 4700. It's giving me an IP6 address, but it's giving me two A records. And that just means that there's redundancy there. It's got more than one DNS server, so this is just redundancy. There's 238 and 239. That's all that is. We can do another one, something like, say, udemy.com. There it is. So it just gives me right there. I'm looking at the IP4 addresses there. And another thing you could do is look at different kinds of records. So I could do NSLookup, and what I'll do is I'll just hit enter. Now I get to this command line here, and I can do set type equals MX. So I want to look at MX record. These are email servers. So I do here, say for instance, teachable.com. So those are the mail exchangers, the mail servers, SMTP servers. And these are just the host names for them. So this is what happens is when you send email with SMTP, it's going to go to DNS and try to find the mail servers where it's going to relay it. And these are some of the examples here. Alt 3 ASPMX is just the host names of them. I could do another one like what else? Udemy.com. We could do that. See what their records are. There it is there. It's showing Alt 3 ASPX and Google. So it's using some of the same. I could also do something like the name server record. Set type equals NS. This is the authoritative server. I wonder what that is. So I do set type, and I'll do youtube.com, for example. So it's using name servers on Google there, and that's 1 through 4. Then I can do another one, for example, say teachable.com. These are the authoritative servers. So there's different names there. So what have I done? So I'll try Udemy. They're using different kinds of names. This is how they've named them, basically. So they're not authoritative. I'm getting the non-authoritative answer, but these are actually where the name servers are, where the ISP DNS resolver would actually go to get the updates if what it had in its cache would actually timed out because of the TTL value. So if they get flushed in the cache, it goes out to the authoritative server again, and then would just have to do a request and then cache it locally again. So that kind of gives you an overview of NS lookup. It's important to know it as a web developer, to know it as a tool. There's also Dig that I'm going to show you how to use as well, and that is actually something that's it's Linux based, but there's an online version as well. In this video, I'm going to introduce you to a tool called MTR. MTR combines both ping tool and also traceroute into one tool for monitoring network path metrics. So from the previous lectures, you know that network path metrics is really network layer metrics. So it involves things like latency and packet loss. So just to do a quick review, network latency is basically comprised of 5 different components. There's propagation delay, queuing delay, device processing delay, transmission delay, and protocol delay. So it's really accumulation, all those different effects from client to server. And then you multiply by 2 to get your round-trip delay. And propagation delay is the main culprit of any network latency. It's the one you want to reduce the most. And contrary to what you might think, copper and fiber actually have a similar propagation delay. Propagation delay is defined as the latency or delay you get when you put a signal on a wire from a client and send it to a destination in one way. Then you multiply by 2. Copper and fiber actually have the same propagation delay. It's 2/3 the speed of light. And that might kind of surprise you since fiber is a much better quality cable. And it is actually. Its characteristics are better as far as you can go longer distances at higher bandwidth. But propagation delay is something else. It's just sending a signal through a network media. And when it comes to copper and fiber, that specific definition, there's really not a lot of difference. So if you have say you had a straight line across the United States, 2,000 miles, and you're sending a signal through the network media, whether it's copper or fiber. Now, specifically just a propagation delay, you could calculate it by dividing 2,000 miles by 125,000 miles per second. So the 125,000 miles per second is just 2/3 the speed of light. And that's how you calculate propagation delay. So you end up with 16 milliseconds one way. That's what you'd get. It's not really a constant, but it is the only what you call a somewhat fixed latency, because it's based on this constant of distance divided by 2/3 the speed of light for copper and fiber. So that is actually 8 microseconds per mile you're going to have delay. So you have to do something, and it's all based on distance. It's not based on the media. It's just based on distance between client and server. And the reason why CDNs are so popular, because you want to reduce that propagation delay as much as possible, particularly when you're on international circuits. Queuing delay has to do with network congestion primarily. There's other things that could cause network congestion. There's just a variety of sources, really. But what happens is that you get network congestion, you get a queuing of packets. And the queuing of packets then can lead to packet loss when you get tail drops. So what happens is you get queuing delays of packets waiting in the queues and not getting to the destination. Then you have device processing delay, and that is routers, switches, and firewalls, like routing lookups and MAC address table lookups, rewrites, and applying network policies, for example. Then you have transmission delay, and that's based on bandwidth. So the higher the bandwidth, the lower the transmission delay, because you can get the bits onto the wire faster. And protocol delay has to do with handshakes for TCP, DNS, and TLS, primarily in the context of what we're discussing right now. And it's also TCP flow control as well. So the drawing here I've got is just a topology with a client connecting. It's got a last mile to this R1, the default gateway. It could be the ISP local loop. Then you go to service provider, back to a internet router, and onto a switch. So what I'm going to do is do an MTR from client to web server and take a look at what's happening there. So I'll just do MTR 172.16.2L1. This is a Linux program, but there's also a Windows version as well. So you can get it free with Linux. So I've got 5 hops here. So that's the first thing you notice, 5 hops. The first one is to R1. That's the top one, that 254. Then it goes to the ISP. Then it goes to the iNet router. And then it goes to the switch, and finally to the web server, 172.16.2.1. So what happens is, since I didn't run a report, if you do a report, it'll just send 10 packets and give you a report. I didn't do that, so it's going to just keep sending these packets. So the sent column is just a packet. You see how that's increasing. The loss percent is the packet loss. And that's the percentage of packets that are being dropped for whatever reason. And that's just a percentage based on the number that were sent and the number that were received. So you can see that 200, 222, there's some starting packet loss. And that doesn't necessarily mean there's a problem. A lot of times when it's routers and firewalls, they'll have control plane policing. So it actually is it's an ACL that drops some of the ICM packets purposely as a part of policies to prevent denial of service attacks. And that's a really common thing. So it's typically not something to concern yourself with when you're going through these routers and you see that kind of thing. Routers typically do that. It's a little misleading, but that's typically what it is. It could be something else to investigate as well, but you have to consider that sometimes that's what it is as well. It's getting to the destination. And here there's some other columns. There's last latency, average latency, best latency, and worst. And then there's a deviation, just means it gives you a number. So if there's swings between, say, average and best and worst, you'll get a higher deviation. So you want a low deviation. So the average here is 27, then 30, 33, 50, and 39. So they're all pretty good. Packet loss for data applications, as long as it's less than 5%, that's typically not a problem. Even up to 10%, you might not notice a difference. But when you get to 18 to 20%, it's something worth investigating further to kind of get a better understanding of, is there network congestion? Is it temporary or is it ongoing? It's just a point to investigate a little bit more. The actual latencies are quite good, so that would suggest to you that the circuit is pretty healthy. When you look at all this, you wouldn't concern yourself. Although the packet loss, if it stays high like that over a long period of time, you'd kind of want to know why that is happening. Do a little bit more investigation. So you can see here, these are the numbers here. The packet loss starts on 200, 200, 22. So there it is there. So that's the internet router. So this is ingress. This is actually giving you all the inbound readings. So it'll take it a gig 00 inbound here, and it also gig 00 right here. And then the next inbound would be right over here. Wouldn't do anything on this gig 01. And then the next one, 172.16.1.2 on the switch. So some packet loss starts here. Could be some network congestion. And it goes down to the web server there. So all in all, it really doesn't look too bad. The ICMP is sometimes a problem. If you get all question marks, that means typically if you can get question marks there, but as long as that's not the last device that's doing it, you're okay. If you get all question marks on the last device, typically the device is down. That's what it indicates. So you have a problem there. If you get it on one of these other hops, often it's there's some problem with it's just not permitting ICMP, not allowing the ICMP packets to return. So typically it's not a problem as long as you can finish the trace okay. So basically, you really, when it comes to MTR, you really want to look at what's happening really on the last 2 or 3 hops. That's really where you want to focus things to understand if you have a healthy network layer connection or not. So this is a really good tool for troubleshooting. There's just a lot that you can do with it. The other thing is you want to make sure when you're doing testing to do it from both directions. So I want to start on a client. I should also start it on the web server because this is just giving me the forwarding path measurements. The return path, I don't know what return path it's taken, I have no idea. I'm getting a round trip time on it, but I don't know what the return path is because it's on the return path, it'll start hitting different interfaces, right? And also potentially take a different path with a higher latency. And that's the other thing you want to know is where the latency is. All I'm getting is one reading here on the latency, but you take this maybe 46, for instance, now it's 43, this 4th hop. So with that 4th hop on the return path, that could be 35 milliseconds of it could be in the return path and only 10 seconds or so in the forwarding path. So that's why it's important to do a trace in both directions, both from client and from web server, and compare both. That's a really important practice when it comes to network layer troubleshooting. In this lecture, I'm going to give you an introduction to firewalls. So to start with, firewalls, they're prevalent in all the enterprise network as well as service provider. So it's something that web developers need to know something about. They're almost as important as TLS and DNS. As an intermediary device, it will affect your application. Firewall is a network service that prevents unauthorized traffic on a network. That's its primary service. You have 2 types of firewall architectures. You have stateful and stateless. What I'm going to describe in this video is mostly on stateful. Stateless operation has to do with things like AWS firewalls or access control lists with Cisco. And stateless is it doesn't manage state or have any understanding or awareness of bidirectional state. It's just a filter on an interface. And you can have access control lists in both directions, and neither ACL knows that any others are connected. It's just a stateless basic filtering process. Stateful is a little bit more complex and more secure. So the network deployment of stateful is mostly physical appliances, but you can also get software firewalls, virtualized firewalls. When it comes to stateless, most of that is going to be in the cloud. With, like I said, AWS, for instance, or host-based firewalls are stateless, as well as web application firewalls. So to start with, the static-based rules of a firewall, whether they're stateful or stateless, what they will do is permit or deny traffic between source and destination. So they're static-based rules. As a web developer, you submit an open port request, and the direction is irrelevant with stateful. You just open up a port. You don't have to consider direction with stateful firewalls. You just say you want a port open on a firewall, and that's all you have to provide. So the firewall logical topology kind of looks like this. A firewall is typically a DMZ device, so it's got multiple interfaces with different security levels. So you've got an inside interface, you've got an outside interface to the internet. You also have what's called a DMZ, which is a little of both actually as far as security level goes. The outside is zero, meaning nothing is allowed unless you permit it. So that's called a zero model, zero trust model. So you have to explicitly permit something or it won't be permitted. ACLs work differently. A stateless ACL access control list, will let everything in through a router interface unless you tell it it's not permitted. So the architectures are quite different, and that's something to keep in mind as well. The inside interface is 100. That's this is a Cisco firewall example. That means that's the highest level. So you're going to have to, if your traffic goes from outside to inside, you're going to need to have explicit ACLs on that firewall to allow it. And I say ACLs, the firewalls use the same syntax as a Cisco access control list, but it is a firewall rule, so it operates differently than you would on a router. So just not to keep things confusing, I don't mean to do that, but they are ACLs. They use the same syntax, but they work under different conditions, put it that way. And the DMZ is just a 50 level, so that it's somewhere between 0 and 100. So typically you can have public servers in the DMZ, web servers. Maybe they're using HTTP 80 or 8080, for example, instead of HTTPS. Of course, it's just not the same level of security that's required often, not all the time, but often, that you require on the inside interface. So it's set up as a 50 level. And then on the inside, of course, you have your web service and such. Stateful firewall is typically at the internet edge, as you can see here. And I've discussed the interface levels. And like I said, traffic permitted to pass from higher to lower level by default as well. So when you're going from inside to outside, it is permitted by default. So it is bidirectional, but understand that when you set a firewall rule, the outside to inside is where the filtering is going to take place. It doesn't take place in both directions. It doesn't need to. And that's a key part of this idea of it's not directionless, but it's only in one direction when it comes to security. When that packet turns around and goes back from inside to outside, it will be permitted by default because it's part of that flow. So you don't have to have a separate rule. Transport layer firewall. So there's two here. I'm going to discuss transport and application layer. And you can see by the model here, the transport, that is the TCP and UDP layer. So if anything works at the transport layer, it has visibility into any lower layers, such as the IP addressing. So when you set up a firewall rule, or an ACL, same thing, you're going to specify often IP address, source and destination IP address, as well as application ports, whether it's TCP or UDP. And this is what basically constitutes the firewall rules within the transport layer firewall. That's what it's looking at, that information. Source and destination port for those application ports, and source and destination IP address. It's kind of multi-protocol. The application ports could be a variety of applications, whether it's DNS, HTTP, just really any other kind of application where you want to provide filtering. And they are static-based rules as well that are based on permit or deny. Here I've just got just a reminder of the application ports. HTTP is 80, HTTPS is 443, SSH is 22, Telnet is 23, FTP is 21, SMTP is 25 if it's clear text unencrypted, or 587 if it's secure. And then DNS can use either. That's based on the type of query. And NTP is UDP 123, SNMP is UDP 161, and MySQL is TCP 3306, just to name a few examples. So here I've got a TCP segment, and this is the TCP header, in other words. Segment is just the word for it. So the firewall is going to look into the TCP segment when it's filtering based on some application. For example, 443, it's going to look at the destination port is 443 and whatever the source port is. And it's going to look into that and do filtering based on what is there, whether it's permitted or denied. So that's just basically showing how it's looking into the TCP header and taking a look at that addressing. DNS, for example, it'll have a destination port 53 and some source port. Application layer firewall. So the visibility here is right up to the application layer, so you can see it It can look at the protocol header as well as data body. When I say protocol header, I'm not talking about HTTP alone. I'm talking about any application. They all have their own headers with DNS, SMTP. They also have the data body as well. So application layer firewalls can really look into that application layer and do inspection at that layer. It can look at URLs, methods, cookies, and do filtering based on that. And it can also do filtering based on TCP and UDP application ports, as well as source and destination IP address, as you would well imagine. So it has visibility into all layers, and it does, like I said, a dynamic analysis of the header content. And with the application layer, it's really looking for malicious code at that point. It's not really filtering so much in terms of, it is doing security, but it's really looking for malicious code. When you've got an application layer firewall, like a web application firewall, it's really scanning for problems, for malicious code that could be injected into the application layer itself. So it's designed mostly for web-based application. Then the application layer firewall, this is just shows a connection model here. So the network layer, and it also will straddle transport and application layer. So it just shows a firewall working at all those layers there for an HTTPS session, for example. So that just shows the device connectivity. Stateful firewall operation starts with your request to open a port on the firewall for an application. So assume you've done that already. The firewall rule is created to permit or deny application traffic. So it's an access control list, essentially, in terms of the syntax itself. So the client initiates a session to the web server. And when it does that, a flow is added to the firewall connection state table. It's the first thing that happens. Then the firewall verifies state for each flow to prevent security attacks. So there's two types of state flow. TCP is a stateful protocol. So the firewall will look at ACKs, sequence numbers, things like fin flags and SYN flags, and it will know if you start a session whether it should be a fin flag or SYN. It will know that, and will know what should be required in the opposite direction. So it will track all that in its state table. And if something doesn't make sense, it will turn off that session. So it understands TCP very well and what should be expected based on direction and what it is you're doing. UDP is not stateful, it's stateless. So all you get there is really a timeout, the state table. So that's the most you can do with UDP, is you'll get a timeout. If a session times out for whatever reason, the session will be dropped. But UDP applications through a firewall don't provide, the firewall can't provide stateful services because the protocol is not stateful. So if you look up here, I've got two paths here for what happens, kind of a flow. So you have an existing connection. So the firewall says, is this existing? If it's not, it will go to an ACL match. It'll see if there's an ACL match. And if there's no match in it, it'll drop it. If there is, it'll say, okay, this is permitted. Then it'll go on to stateful inspection. If there's no problem with the stateful inspection, with the flags, with TCP, for example, or UDP timeout, if everything is fine with the state of the flow, and it'll send it off to a routing lookup, and off it goes. If it doesn't, it'll drop the packets. Now, if it's an existing connection, the ACL match is already done, so it's already allowed. So that's part of stateful operation. It doesn't have to keep doing it. It only does it once. So if it's an existing connection, it'll have that flow in the state table, and all it does is just checks to make sure there's no problems with the state itself. If there isn't any, then it goes off for a routing lookup. If there is, it'll drop it. And this is just kind of a stack application topology. So here I've got a web server, an application server, and MySQL database. And the firewall's got a bunch of TCP and UDP flows going through it based on the firewall rules and the connections between whatever clients are connected and servers. And so I've got some addressing here as well. So the 200 is a public address. So it's connecting from outside the data center into the data center. So DNS has already been done. It's got an A record, so it connects. And the firewall rule is permitted. And when you do firewall rules, you actually assign them to the outside interface, is where the security filtering happens. So you will assign it on the outside for that inspection. So basically the public interface. And the reverse path is implicitly allowed since flow exists in the firewall connection table. And this is a firewall connection table, so a little bit more detail here of the same thing. So you've got in the connection table, you've got the protocol on the far left there, what kind of protocol it is. So if you got, whether it's, that's based on the type of application, of course. Then the outside would be the client address and port. Then the inside would be the server address as well as destination port. And then the flags would be whatever common flags are associated with that flow at that time, whether it's an ACK that's being sent or whether it's a SYN or FIN or something. That's part of the TCP state operation. And basically it just goes through UDP. I've got another example of UDP. It doesn't have any state information because it doesn't do flow control. So it just has an idle timer of 90 seconds. So a little bit more basic. That just gives you an overview of just what the connection table looks like, packets flowing in from the outside. Configuring a firewall rule. Firewall themselves are just basically ACLs that permit or deny packets between source and destination. They're static, and then you can apply them to the inside outs or DMZ actually. Most of them are applied to the outside. That's where you're going to apply them. There are times when you apply them to the DMZ interface for the DMZ services, but most of them are on the outside actually going in. That's where you want to apply them. And I've got some examples here of some firewall rules. And this is really just standard. It's not something you need to know too much about, but I just include it anyway. Just if you read from left to right, these are quite easy to read. This is an access list, HTTPS, for example. It's extended, and that means that my intention here is to filter an application protocol like DNS, like HTTPS, like SMTP, FTP, you name it. I'm actually doing filtering in the transport layer. And then I'll do a permit or deny. So I'm going to permit this. Then I include the source. So that source would be anything from 192.168 subnets. So that's a lot of subnets. That would be from the clients themselves. Anything from that that are within that subnet range will be permitted. And the host would be a server. The server address 172.16.2.1. So that's the web server. And EQ means just allow 443. And that's basically how a firewall rule is read from left to right. And I've got some other examples. 8080, that would be maybe for a DMZ. 3306 would be for SQL, and 53 for DNS. I used to use conduits, and then they just went to these access control lists that basically are very similar to what's used on routers.